Hello class. So I want to go over a function transformation problem. I was doing some at office hours and then I also realized that on Newton, a lot of it is multiple choice. So you're not being asked to graph anything by hand. And on the exams, you are going to be asked to graph transformations by hand. So I want to make sure I give you guys some tips. Um, there's usually a way I explain it in class that seems to help students because it breaks it down piece by piece and it's a little more visual and you kind of use the points to help guide you on your transformation. So the question says, given the graph of f, so this is the graph of f here, um, what we want to do is we want to graph this transformation according to the way we're going to be changing the function. So first thing before you even start figuring this out is you got to identify what the transformations are for this given question here. So let's do that real quick. So you want to start. As you know, there's horizontal transformations that are going to affect the x values, and there's going to be vertical transformations which affect the y values. And as you've been seeing on the homework, anything that is a horizontal transformation and what you normally see inside of the parentheses of your function here, what's tricky about them is that actually what you see here is you're going to be doing the opposite in terms of a transformation. So for example, I see this x plus 1 that's inside the parentheses of my function, so I know it's going to be a horizontal transformation, but now we got to identify what it's going to be. So when I look at this here, I'm seeing visually that I'm adding 1 to x, but what really happens in the horizontal transformation, this is going to be a horizontal shift, and what ends up happening is the opposite. So instead of increasing your x values by 1, we're going to be decreasing our x values by 1. So you're going to be shifting to the left. So you want to write a note of what that's going to do because we're going to use that. So what we're going to do though is we're going to pick points on the original function and we're going to be applying these transformations to either the x coordinate or the y coordinate. So you want to write down what this transformation is doing. We know it's affecting the x coordinate and it's going to be doing it in the opposite manner. So we're really going to be subtracting x by 1. Okay? So we're going to be we're going to write subtract x by 1. Then we look at this other here, the number 2, and we notice that it's inside the parentheses of my function, so it's also going to be a horizontal, in this case it's going to be a horizontal compression. It's tricky though because you see the 2 multiplying with this expression with the x, but remember it's going to do the opposite. So instead of multiplying by 2, you can think of it as either dividing x by 2 or multiplying x by 1/2. Because dividing something by 2 is the equivalent of multiplying it by 1/2. So let's say I'm going to write that we're going to multiply x by 1/2, okay? So we're going to multiply x by 1/2. So notice that I'm writing down which variable I'm affecting, and I'm writing down the operation that I'm going to be doing to it in a little bit. So these are the horizontal transformations. Anything that's outside of the parentheses of my function, like this negative and this plus 1, that affects the y value. So those are going to be vertical transformations. So this negative here, think of it as a negative 1 multiplying your function, which, remember, your function gives you the outputs, so it's really affecting the y values. And unlike a horizontal transformation, whatever you see it visually doing to the function here, it doesn't do the opposite. It actually will do what you see. So in this case, we're going to be, you're noticing that the negative 1 is multiplying with the function. So what ends up happening is that the y values of your original function that end up being multiplied by negative 1, which is what does the reflection. Okay? So this guy is going to give you a reflection, but the way you're going to reflect it is you're going to multiply y by negative 1. Okay? All right, so we have that one. Here we have the plus 1. It's outside of my parentheses of my function, so I'm again going to be affecting the y value, and I see that I'm adding 1, and it'll do what you visually see. So we're going to add y by 1 value, okay? The other thing, once you've identified what the transformations are going to do, another important thing to keep in mind when you have so many happening is there's actually an order that you want to do this just to be safe. Sometimes the order doesn't matter, but on other times it will matter. So just to be safe, you kind of want to think of it as PEMDAS, okay? So you want to deal with the inside of my function parenthesis first. So I want to first apply my horizontal transformations. Then we'll apply what's outside the parentheses. So then we'll apply the vertical transformations. But in some examples, it also matters which one do you do first. Do I subtract x by 1 first, or do I multiply it by a half first? So again, use PEMDAS when you're doing this. And we're going to do multiplication, and then we'll do subtraction. So in terms of the order of how you're going to affect the x and the y coordinates, we're going to be doing this one first, because it's multiplication, it's inside. Then we'll do this one second. And then we go outside of the parentheses, but I got to do multiplication first. So I'm going to multiply this as my third step. And then lastly, we'll add. So that will be my fourth thing I'm going to apply as a transformation, okay? So I kind of note down each different transformation. I write down in order that I'm going to do it. And then what you're going to do, once you have all these notes, you're going then to pick points on the original function, okay? The graph of the original function. And so you want to pick some good points with some nice, easy x and y coordinates. So for example, this point here, that has x coordinate 0 and y coordinate 1, 2, 3, 4. So this is 0, 4. And this point here is 1, 2, 1. So it's 2, 1. So then what you're going to do is you're going to get these points, and we're going to apply the transformation step by step. And so let me show you what we're going to do with that. So let me write down this point here, 0, 4, and then 2, 1. Okay. So I'm going to now apply the transformations. My first transformation is I'm going to multiply the x coordinates by 1/2. So I'm going to multiply this x coordinate by 1/2. I'm going to multiply this x coordinate by 1/2. And so then what I get, 0 times 1/2 is just 0 again. I leave the y coordinate because I'm only doing one step at a time. 2 times 1/2, that turns into a 1. So that will be a 1. So notice that what happened is that your graph, this x value, this point stayed the same, but this point got moved over here so that you're compressing it horizontally. Okay, so you're like squishing the graph. All right, so we did this guy to these points. Now we're going to apply the second transformation, and we're going to subtract x by 1. So I'm going to subtract this x by 1, subtract this x by 1. And so we're going to get -1 here. I leave the y value by itself. And then 1 minus 1 is 0. So then I leave the y value by itself. So notice that these points, and then this one that got moved here, now they got shifted to the left one. And that's exactly what this transformation is doing. It's doing the opposite, shifting to the left. All right. So now I did my second transformation. Now we're going to do the third one, where I'm going to multiply y by -1 to reflect it. So I'm going to multiply y by -1, multiply y by -1. So then we get, now we leave the x value alone. And I'm going to multiply 4 by -1. That's going to give me -4. I'm going to multiply, we leave the 0 alone and multiply 1 by -1. Turns it into a -1. All right, so we've done this transformation. So now notice that these points are down here. They got reflected. And then my last one is I'm going to add the y values by 1. So now I'm going to add the y value by 1 here, add the y value by 1 here. So then I leave my x value alone. I got -4 plus 1 will be -3. And then I leave my x value alone. And then -1 plus 1 is 0. So then these are the final points that I'm going to be using, and I'm going to plot them. Let me do them with a different color. Let's do pink. So this point, 0, 4, got transformed, and so now it's at -1, -3. 1, 2, 3. So it is now down here. And this point got moved over to 0, 0. And so notice that because there was a reflection involved, this point got moved down here, and this point got moved over here. And so I know that I have to connect this point to this point in this kind of curvature way. So I would graph this point and connect it with this point, like that. Okay? And so then that's going to be the transformation. And let's just confirm it. Let's see. So this compresses it by a half. So now it's like a little bit more squished. Then it got shifted to the left. So everything got shifted to the left. And then I had to reflect it so that everything went down here. And then I had to move everything up by 1. And that's exactly what this gives us. If you're comfortable moving the graph and manipulating it on your own in your head, that's totally fine. But if you get really lost by looking at all this, remember you can graph some points, write them down, and then step by step apply the transformations to either the x-coordinate or the y-coordinate. And then at the end, plot those points, but then just be very careful that the way you connect the points that you moved has the same shape as the parent function, right? It can't be like, it's not. I know it's not a line, because this has to have a similar shape to my parent function. Okay? All right. I hope this helps. Have a great day. Thank you.